Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to move on to the next exercise of trigonometric functions from class 11th. Yes, we are discussing class 11th chapter 3 trigonometric functions, and today we will be talking about exercise 3.4, which is based on solving trigonometric equations. Trigonometric equations wherein we actually find the values, the principal values and the general solution of simple equations based on trigonometric functions. Sin x equals something, cos x equals something, tan x equals to something. You are supposed to find the values of x, and the principal values are asked, and sometimes the general values are also asked in such questions. Now this is one of those topics which is a favorite for the JEE people as well. If you are preparing for any competitive exam in general, you will be asked questions based on this topic. What about NCERT? If you are preparing for the school examination, this is once again a very important topic from that perspective as well. And in general, when you talk about, let us say, physics and chemistry applications of trigonometry, you will find that you are sometimes asked to find some unknown angles wherein you will require concepts learnt over here in this chapter, right? So once you have covered this complete chapter, what we'll do here is we'll discuss all the questions asked in exercise 3.4 in NCERT. So let's begin with the first question. What does the question say? Take a look at this. Find the principal and general solutions of the following equations. We are supposed to find the principal as well as the general solutions of the following equations. Now principal solutions, you may recall, principal solutions lie in the interval 0, 2 pi. That is 0 to 360 degree, or precisely 0 to 2 pi. That's the range in which principal solutions lie. Principal solutions. That is solutions lying in 0, 2 pi. The values of x which lie in this interval have to be found for principal solutions. And for general solution, we have some results related to general solution. Let me represent those results once again in front of you. If, for example, if you have sin x equals sin theta, sin x equals sin theta, and you are supposed to find x, theta is known. So this gives me x will be equal to n pi plus minus 1 power n theta, where n is any integer. Where n is any integer. Please observe carefully. This is what you get. Sin x equals sin theta implies x equals n pi plus minus 1 power n times theta, n belongs to integer. There is a simple proof of this, but I am not going into the details of the proof. I am just telling you the final result. This is the final result which you should be aware of, you should memorize. Cos x equals cos theta implies, what is x equal to? X will be equal to 2n pi plus minus theta, where n belongs to integer. N can be any integer. Now this is a general solution. All values of x satisfying this equation will come from here, right? And all values of x which satisfy this can be found here. That is something which you should be aware of. Next, one more result related to tan. X equals n pi plus theta. Please observe, this is n pi plus theta. N pi plus theta, where n is any integer. What happens in case of cot, sec and cosec? Cot is simply the reciprocal of tan, so you'll have to convert that equation in terms of tan. In terms of sec, convert it once again in terms of cos, and in terms of, let us say, cosec, first convert in terms of sine, and then you can answer this question very easily, right? Is that all? Yes, that is all from the point of view of concepts. If you are aware of these concepts, you can very easily solve this question. Tan x equals root 3. Now, one more thing would be required is, for finding the principal solutions, what do you have to take care of? For tan x equals root 3, one simple analytical approach. What does the analytical approach say? Analytical approach says that you will have to guess, okay, tan x equals to root 3 implies x will be equal to pi by 3. That is one of the angles. But then the other angle, for the other angle, yes, you will have to think further, and which allied angle satisfies this particular condition is something which you have to find. But let me tell you one more approach, okay. What is that approach? Tan x equals root 3, okay. So imagine if there would have been root 3 or minus root 3, I would have thought about a very unique angle in the first quadrant only. That is this pi by 3. This is pi by 3. Tan x equals root 3 at for x equals to pi by 3, right? That's one of the angles. and the other angle can be found in another quadrant. Which other quadrant will we consider over here? Tan x equals root 3 implies tan x, the value of tan x is given to be positive. Now in first quadrant all are positive, in the second sine is positive, in the third tan is positive, and the fourth cos is positive. So yes, the other value would lie in this quadrant, in the third quadrant. Okay, how do we get that value? This value will be obtained directly by adding a pi by 3 over here. This angle will be pi by 3. Use this line, right? So this is pi, and this angle overall would actually be pi plus pi by 3. This angle overall would be pi plus pi by 3, and you can check that over here with me as well, right? I'll explain all concepts logically from there, and then we'll solve the complete question over here analytically. What do we have? Tan x equals root 3, and we know that root 3 is actually tan of pi by 3, implies x equals pi by 3. This is one of the principal solutions, mind you. There will be another principal solution here, and what will that principal solution be? Let's take a look at this. Also, tan of 4 pi, what do we have? 4 pi by 3, tan of. Now where did we get this 4 pi by 3 directly? The NCERT people don't talk about that, right? And I have explained you a logic behind that, right? And you can now guess where do we get that angle from. So remember, tan of 4 pi by 3 can be written as tan of pi plus pi by 3, and tan of pi plus pi by 3 is also equal to, tan of pi plus pi by 3 is also equal to tan of pi by 3. Very interesting, yes. And tan of pi by 3 is further root 3. So therefore another value of x, therefore tan x equals tan 4 pi by 3 implies x equals 4 pi by 3 as well. Now this is one principal solution, this is another principal solution. At max there will be two principal solutions for any simple equation of this kind, right? Okay, so what do we have over here? Therefore principal solutions, when you talk about, first we are finding the principal solutions. X equals pi by 3 and 4 pi by 3. That's the answer in case of principal solutions. What about general solution? General solution is relatively simple. You find any of one of these values, and in this question it is pretty simple. Tan x equals tan pi by 3. Okay, since tan x equals root 3, I know that root 3 is tan pi by 3, therefore I can write it in this form. Once I write it in this form, then I can very easily write the general solution. Therefore general solution will be x equals n pi plus theta, it is n pi plus pi by 3, where n belongs to integer. This is the general solution. Now, a question arises that I could have written this tan 3 equals tan 4 pi by 3 as well. Yes, I could have written this equals tan of 4 pi by 3 as well, and in that case I would have obtained x equals n pi plus 4 pi by 3. Yes, you would have obtained that. The solutions, the actual solutions that you obtained in this and in that will be exactly same. The form may look different, they may look different, but the solutions obtained would be exactly same. Once you start writing the solutions for different integer values, for example, in this case, for n belongs to integer, what are the solutions that you will get? Please note, what are the solutions that you will get? Let's put n equals 0, so pi by 3 is one of the solutions. Let's put n equals 1, so pi plus pi by 3, which is 4 pi by 3 is a solution. N equals 2, this is 2 pi plus pi by 3, which is 7 pi by 3 is a solution. Similarly, 10 pi by 3 is a solution. For n minus 1, for n equals minus 1, what you will get is minus 2 pi by 3 is a solution. Minus 5 pi by 3 for n equals minus 2, this will be minus 5 pi by 3, and so these are the solutions that you obtain over here, right? There are many solutions, general solutions. Since trigonometric functions are periodic functions, yes, they repeat after certain intervals. The values of trigonometric functions repeat after certain intervals, they are periodic functions, right? For sin x and cos x, the values repeat after intervals of 2 pi. Whereas for tan x, the values repeat after interval of pi. So these are periodic functions with different periods, yes. So values repeat after certain intervals, right? So many solutions are obtained for any equation in this manner in case of general solution. Therefore, we have a method of representing all of these in this form, right? What about principal solutions? Principal solutions are found in the interval 0, 2 pi only. Okay, and many a times in competitive exams, what you are asked is, you are given some interval. Let's say the person would give you minus 4 pi to 4 pi. Okay, find number of solutions in this interval. So in that case, you'll have to deal with a combination of principal and general solution concepts, right? So keep those things in mind while attempting questions. That is all for this question over here.